Hello, welcome to the lecture session on complex line integral. Complex integration. Integration of complex valued functions defined along a curve in a complex plane is called complex integration. So let us illustrate with one curve. Consider a continuous function f of z of the complex variable, say z is equals to x plus iy, defined at all points of the curve C extending from P to Q. Now let's divide the curve C into n parts by arbitrarily taking the points. So from P to Q, you can observe in the diagram, P to Q, there are n number of divisions. That is P0 of Z0, P1 of Z1, P2 of Z2, Pk minus 1 of Zk minus 1 some point, and Pk of Zk up to Pn of Zn. Okay, so this is the curve we have taken and it has been divided into n parts. Complex line integral is denoted by integral f of z dz, where f of z is complex function, that is a u plus iv is a complex variable, and dz is dx plus I dy. The properties. First property, if minus c denotes the curve traversed from q to p, then integral along that minus curve f of z dz will be minus of the integral along the curve f of z dz. That is the first property. Next, if C is split into number of parts, say C1, C2, C3, etc., then integral along the curve is also split into integral along the first curve plus integral along the second curve plus integral along the third curve, that is integral along C1 f of z dz, and so on. Next property, if A and B are the constants, then it is like a linearity property. Integral along C of A f1 of z plus B f2 of z into dz is given by A, which is a constant taken outside, A integral along C f1 of z dz plus B integral along C f2 of z into dz. These are the various properties, the three properties mainly we will be using it while solving the different problems. Let's see the first example. Evaluate integral from 0 to 2 plus I z bar square into dz along, first one, the line x is equals to 2y, the second one, the real axis up to 2 and then vertically to 2 plus I. So here the line x is equals to 2y is a straight line, and a real axis, the second one is a real axis up to 2 and then vertically to 2 plus I. That means it will move like a L shaped in the reverse order. Solution, along x is equals to 2y, we get dx is equals to 2 times of dy, and z varies from 0 to 2 plus I. This implies x comma varies from 0 comma 0 to 2 comma 1. How we are getting 2 comma 1 means it is 2 plus I, where 2 is the real part and 1 is the imaginary part. Next, integral from 0 to 2i z bar the whole square into dz. This gives us integral along 0 to 2 plus I z bar the whole square if we are taking. Actually z is x plus iy and z bar is x minus iy, which whole square if we are taking x square. Here we get minus y square because it is iy the whole square. When we take it will become minus, and minus I into 2xy dx plus I dy because dz is dx plus I dy. Next, when we simplify this, we get 2y square, 2y the whole square because x is equals to 2y. On substituting 2y the whole square minus y square minus I into 2 into x is replaced with the 2y into y of 2 times of dx is 2 dy, which we know, plus I into dy. Now everything has been converted into y terms. So what we are getting? We know that y is varying from 0 to 1. So even the integral limits also will be taken as y only. So y is varying from 0 to 1, and on simplification we get 3y square minus I into 4y square times of 2 plus I dy. So what we will be getting is integral y is equal to 0 to 1 3 minus 4i y square into 2 plus I of dy. That gives, since 3 minus 4i and 2 plus I is a constant, only y square remains inside the integral, which on integration y cube divided by 3, which is 0 to 1. So on simplification, the real part is 6 plus 4, that is 10, and the imaginary part is minus 5i divided by 3, which gives us 5 by 3 times of 2 minus I. Next, let's go for the second part, that is real axis, which implies x-axis 2, 0 and vertically 2, 1. Diagrammatically, when you represent, it is the curve is moving along the x-axis up to 2, 0 and then moves vertically upwards till it reaches the point 2, 1. So O, P and then Q. So when it is moving from O to P, 0 is the value of y, only x is varying from 0 to 2. We can observe in the diagram. And when it is moving from P to Q, we can observe only y is varying from 0 to 1 because x is equals to 2, which gives dx is 0. So along OP, y is equals to 0, which implies dy is equals to 0, and x varies from 0 to 2. Along the PQ, x is equals to 2, which implies dx is 0 and y varies from 0 to 1. Next, we get the integral as first integral, since there will be no variation in y because it is moving along the x-axis only. So x is varying from 0 to 2, it is x square dx, plus in the second curve, that is P to Q, along the PQ curve if we are taking, it's only y which is varying, that is y is 0 to 1. So we get x as 2, that means 2 square 4 minus y square minus 2xy, which will be 4iy into I dy, because when x is 2, dx will be 0. So an entire term is considered along with y. Now x square when integrated, it will be x cube by 3 varying from 0 to 2, and I times of 4y on integration minus y cube by 3 minus I into 4y square by 2, which varying from 0 to 1. So on substitution, we get 4 minus 1 by 3 minus 2i, or 8 by 3 plus 4i minus I by 3, plus 2. Now all this we have to simplify by adding all the real parts and then the imaginary parts. When we add the real parts, it is 8 plus 6, that is 14 by 3, and here we will be getting for the 12 minus 12I minus I, that is 11I by 3 we get it. So the real part is this and then the imaginary part. So 14 by 3 plus 11 by 3I, this is the value of the integral. Thank you. Any doubts? It can be asked.